All right, and we're back at it. So now the other part of lesson 8.2 is problems like problem number 2 on this page. They want you to find the greatest common factor. What is that? That is the number and the variable amounts that you could take out without making a mess. So that's basically what my question is. What is the most you can remove without making a mess? So your GCF skills kind of have to do with your fraction skills. With simplifying skills, when you're simplifying fractions, if you're simplifying a complex looking fraction, how do you simplify it? Well, you take out the greatest common factor. That's kind of what's going on here. So GCFs really aren't that hard to find, and the variables are even easier to find. Okay, so without making a mess in terms of division, okay, in terms of making a mess, what's the most we could take out of a 5, a 25, and a 45? So some people will list them like this. I'm not a huge fan of that. It seems like an extra step that's not needed. So the greatest we could take out of a 5, a 25, and a 45, most of the time you're lucky and it just happens to be the smallest number in the pack. Okay, so in this case, the most we could take out, I'll make it a mess, is a 5. If we tried to divide by anything more, we would get decimals and it would get messy. Okay, now the x values are a little bit different, or actually they're not much different than that. Okay, x values, variables are probably the easiest thing to find when it comes to a greatest common factor. You literally just pick the smallest one. Okay, if you have an x cubed, x squared, and an x, what's the most you can take out without making a mess? A single x. If I try to divide anything by more than just an x, I'm going to make a mess. Okay, so if I take this and divide by x, it just cancels. If I try to divide by an x squared, I'm trying to take away more than what I have, and I'm going to make a fraction. I'm going to make a mess. Same thing with the 5. If you try to divide by more than a 5, you're just going to make a mess. So what you do, you make the super combo hybrid. This is the biggest number I can take out. This is the most variables I can take out. So the GCF to this trinomial, GCF, is going to be 5x. That's it. That's how you find the greatest common factor of a polynomial. What's the most I can take out, number-wise, and then the most I can take out variable-wise without making a mess. I can't do anything more than a 5x. If I try to divide these by more than a 5x, I would make decimals, I would make fractions, and then nobody would have fun, okay? So this is just a lot of big, bad mental math, friends, okay? So by the time I have GCF written, I already know, oh, the most I can take out is a 3. The most I can take out is a single x. There you go. Okay, whoa, where'd you get that? Well, 3, 9, 12. 3 just happens to be the smallest number in this case. And then x4, x squared, x. The most I could take out without making a mess is a single x. So a lot of times you just pick the smallest one. Pick the smallest one in the group. Okay? That works out a lot of times, but it won't always work out that way. I have some examples coming up here in just a bit where it won't always be that way, but most of the time it is. Okay? So double check yourself. If I divide everything by 3, will there be anything left? Not really. That'll cancel. That'll divide nice. That'll divide nice. If I take anything more than x out, will it all be nice? Yep. Okay. So double check yourself with those greatest common factors. Again, take your time, do it right. Slow is smooth, and smooth is fast.